Hi friends, this is Ankit Rass Horo and my project is on robust positioning for geographical routing in MANET. I have completed this project along with Ankit Nigam, that's my project partner, and we are from Weltech Technical University. We need to know the abstract of the project, that is uh, what is it that is we are going to do in the project. So for effective forwarding decisions in geographic routing, there has to be up-to-date positioning of nodes. So period broadcast of beacon packets containing geographic position of nodes, that is the common method that is used by geographic routing protocols for maintaining the neighbor positions. So we find that this process is ineffective and is not attractive in terms of routing performance and update cost. So we propose a new strategy that is called the robust positioning. So the RP strategy is basically based on two steps. The first is based on node movement, which is harder to predict, and the second is nodes, which is closer to the forwarding paths. Both of the strategies, they update their positions more frequently, and a theoretical analysis with a routing protocol, that is the greedy perimeter stateless routing protocol, it shows that the RP reduces update cost and improves routing performance in terms of packet delivery ratio and end-to-end delay in comparison with periodic beaconing. Now we look at the existing system that is currently used, that is the geographical routing schemes that assumes that the forwarding node knows the location of its neighbors, and in periodic beaconing scheme each node broadcasts a beacon with a fixed beacon interval. If node does not hear a beacon, the node considers that the particular neighbor have moved out of the radio range, thus removes the outdated neighbor from the list. So the disadvantages that were in the existing system is that the position updates are costly and each update consumes node energy, wireless bandwidth, and increases the risk of packet collision. These cause packet loss, which in turn affects routing performance as accuracy in determining correct local topology is decreased. So basically, data packets are lost and they are retransmitted, but at the expense of increased end-to-end delay, that is, more time is consumed in the process. So we propose a new system that is a beaconing strategy for geographic routing protocols that is called the robust positioning. It incorporates two rules for triggering the beacon update process. The first is the mobility prediction, and the second is the on-demand learning. It aims at improving the accuracy of the topology along with routing path between the communicating nodes. Now the advantages of the proposed system. The advantages are that the simulation results show that robust positioning can adapt to mobility and traffic load well. And our scheme also eliminates the drawbacks of periodic beaconing, that was the earlier process that is used, and the extensive simulation result confirmed the superiority of the proposed scheme over the other schemes. And these are the modules that we have created for the project that we are about to show you. There are five modules basically, which are network creation module, beaconing information, mobility prediction rule, on-demand learning rule, graph analysis. So there is a short description of all the modules. So we start off with network creation module. This module, in this module, we create a network environment, that is the ad hoc network that we are about to use, and we create a network module with a source node, intermediate nodes, and the sink node, that is the destination node. The technique of robust positioning is carried out in this module. Next, we have the beaconing information. In this module, the node initialization process is carried out. The beacon packets are transmitted to all nodes in the network, and we check the node distance between previous positions and current positions. So this helps in getting a shorter path. Next, we have the mobility prediction rule. This is triggered when there is a change in the location of the node. That means a device shifts from its original position. So the beacon packet is sent when the deviation is greater than the threshold condition and it is also known as acceptable error range, that is AER. Now we have the on-demand learning rule, and according to this rule, whenever a node overhears a data transmission from a new neighbor, it broadcasts a beacon as a response. So the destination node is added to the list of neighboring nodes if it is not already present. Now finally we have the graph analysis, that is, in this module we'll analyze and we evaluate the impact of varying the mobility dynamics and traffic load on the performance of robust positioning. So for each dynamic case, robust positioning generates less or similar amount of beacon overhead as other beaconing schemes, but achieve better performance in terms of packet delivery ratio, average end-to-end delay, and energy consumption. Now this is the system architecture of the project that we are about to do. We can see the sources and the destination, and along with that the transmission range of different sources and the destination, and how it is routed from one device to another. These are the software requirements and the hardware requirements. These are the diagrams that we use for the description of the project, and here it is the snapshots of the project and the source code. So in conclusion, we could say that the proposed strategy is more efficient and eliminates the drawback of periodic beaconing by adapting to the system variation. It adapts to the mobility and traffic load well, and it will yield a high performance. Thank you. चलिए now we'll show you a short demo of how this software really works, or the project really works. We need to enter an IP address that has to send the file. That is, we enter an IP address that is a random ID address, that is, and we need to browse a file, a short file that we are about to send. So we'll send a small document over the network, and we click on send. So after sending, it will show a buffer. It will start buffering. So when we click on send, it starts buffering, and then we get initialization for the project. So the project start initializing, and starts getting the, when we click on initialization, it starts predicting the nodes it has to go through, and it sends the packet over each and every node. So now what happens is we next click on on-demand learning. So by clicking on on-demand learning, we get a idea of how the packet is going to transfer through the network, as each device acts as a router. So we can see there's a source node from which the packet starts traveling, and it's going to the destination. Now we click on mobility prediction. On clicking on mobility prediction, we get a idea from where the node will start and where it will end, and how it will go, which part it will take to go to the destination. So this is how the project really work.